Hello, everyone. Welcome back. Today, we're going to talk about the transformations of functions rules. Now, I think this is a really difficult topic for a lot of people to grasp, but the good news about it is that the way we transform functions, it works the same way no matter what the function is. So, whether it's one of the four main parent functions that we're learning this unit, so quadratic, um, what else? Square root, reciprocal, and absolute value, or whether it's a different function like exponential or logarithmic functions, or one of the sinusoidal functions like sine, cosine, tangent, those kinds of things. It's going to apply the exact same way, just to a different parent function. And so once you know the rules for these, that will definitely help you down the road for any rules going forward into the future as well. Because there's going to be in high school math, there's going to be a lot more transformations of functions in the future as well. Now, when you get to university math, that's not really the case any longer, but all throughout high school math, that's a pretty common topic in the grade 11 functions and the grade 12 functions course as well. All right, so let's get into it. So basically, here we have this function y equals f of x, and the transformations can be applied as follows. We have y equals a times f of k times x minus d and bracket plus c. And each of these has a purpose. So basically, the transformation, variable, so to speak, here, the transformation factors are this a, this k, this d, and let's choose a new color, maybe purple. Oh, I like the purple, and then this c, right? There are four different things in this pattern, so to speak. Now, what about the other things? Well, y and x are just y and x like they would be for any function, and f just represents the function itself. So as you can see, k and d are inside the function, whereas a and c are outside the function. So let's say, for example, the function is y equals x squared. That means that if we have, for example, a transformed function that's y equals a, or sorry, I shouldn't say a, I should say 3 x minus 2 squared plus 4. Well, let's see, what's actually inside our function here? Well, the minus 2 is inside the function, so that would be d, right? 2 would be d. C would be 4, and a would be 3, right? Because a is outside the function. What's inside this squared is everything in the brackets here, and that's only the x itself, and then this extra 2, here, which is acting as our d. So that's what I mean by be careful about what's inside the function versus what is on the outside of the function, because it does make a difference. I often find people mixing up C and D, or mixing up A and K, especially when only one of those exists. Maybe we just have, plus C, or maybe we just have, there's a difference between x plus 2 squared and x squared plus 2, right? Because here, this corresponds to D, right? So D would be minus 2 in this situation, right? Because we have a negative sign here. If we add a negative 2 in there, we'll get positive 2. And then over here, it's outside of our square. It's totally separate. So in this case, C would be 2. So this means two different things and two different transformations. So that's one note I want to make before we even get into this is how can we know what's inside? We have to check what's inside versus what's outside the function and make sure we apply the correct transformation. Because sometimes we might get A and K confused versus D and C confused as well. But with that said, let's get into what are the actual rules here. How do we actually know what transformations to apply here if we're either asked to actually transform them, or if we're actually asked to graph something with transformations, or if we're asked to transform a table of values or a point, or we're asked to just make a list of transformations, because even that's a very common question as well, is just make a list, what are the transformations of the function? And we're going to talk about all that today, but especially the making a list part, that's for sure. Okay, so for A, let's start with A. Let's make A purple now. A means a vertical stretch or compression. Now, how do we know if it's a vertical stretch or a compression? Well, basically, if the absolute value of A is greater than 1, then it's a stretch. And if the absolute value of A is less than 1, then it's a compression. Simple as that. And if the absolute value of A is equal to 1, then do nothing. Okay, so that's the first thing that A tells us. It tells us if it's a stretch or if it's a compression. Because if you think about it, if we're multiplying all of the, the things that the function's been applied to with something great that's where the absolute value is greater than 1, like 2, we're stretching it, right? We're making all the numbers larger, right? On a larger scale at least, right? We're multiplying a bunch of numbers by 2 or 4 or 8 or whatever number it is. Whereas if we're multiplying numbers by something that's the absolute value is less than 1, we're compressing those numbers in the form of a graph. If I multiply numbers by 0.5, now they're only half as big or half as small as they used to be, depending if they're positive or negative numbers. I'm multiplying everything by a half, or what if I'm multiplying everything by a quarter? Now it's only a quarter as big or small, right? And so that's why this is. So if that helps you remember that rule, fantastic. If you're good with just memorizing the rule, also fantastic. That works as well. The other thing that A tells us, this is number one. Number two thing that A tells us is that if A is negative, then reflect on the x-axis is one of the transformations. Now, what if A is positive? Then we do nothing. But if A is a negative number, that's indicating to reflect on the x-axis, right? Because if it's negative, that's indicating a like a scalar by -1. So all positive numbers become negative, and all negative numbers become positive. So it's reflecting across the x-axis in this case. Okay, now f, we know f is just one of the parent functions. So either in these examples, either y equals x squared, y equals the positive square root of x, y equals 1 over x, or y equals what's the last one? Oh, absolute value x. Absolute value of x is the last one, but it can also represent other things as well. But in this course, it's probably for right now just going to be one of those 4 parent functions in general. Now, what about k? Let's choose a new highlighting color for k. Let's choose this nice blue for k. Okay, let's choose a nice blue color here too. Okay, so k indicates a horizontal stretch or compression by factor of 1 over k, over absolute value of k, rather. And so for this one, if the rule is that if 1 over absolute value of k, if this value is greater than 1, then stretch. And if this value, 1 over absolute value k, as opposed to just absolute value of k itself, is less than 1, then it's a compression. So for example, let's say that the k value that we see here is 5. That would actually be 1 over 5, right? 1 over that k value. So we would be evaluating whether 1/5 is less than 1 or greater than 1. And of course, that's less than 1. So that would actually be a compression. Or what if we had the k value is equal to 1/3? Well, 1 over 1/3 is actually 3. And so 3 is greater than 1. So that actually gives us a stretch. So it's always the opposite of what we would think. So it fools us. But what isn't the opposite of what we think is we still have our regular reflection in the y-axis if k is less than 0. So similar to the other rule we just did, that if k is negative, well, there's not a lot of space here, but I'll write it small here. If k is negative, then reflect in the y-axis. And we're doing that for similar reasons to why if A is negative, we reflect across the x-axis. It's similar reasoning there as well. If k is negative, reflect in the y-axis. Okay. The next one is horizontal translation left or right, and also vertical translation up or down. So let's find some new colors. Let's do this nice green for D. So basically, for D, if D is positive, we go right, and if D is negative, we go left. However, this is also the opposite of what we might think it would be, because you might notice there's already a negative sign here. So if you see, for example, y equals x minus 3 squared, well, this negative sign, this is already part of our equation. So this 3 is actually a positive 3, so we're actually going right here. We go right 3, right? Or let's say we have this, y equals x plus 3 squared. Well, actually, this should be a negative here. And so the only way to get plus 3 is to have negative 3 be the d value, right? If we have negative 3, that makes x plus 3. And so for that reason, this is actually left 3. Left 3. And so this is also a situation where it's the exact opposite of what we would assume it is, which is pretty interesting. So yeah, so basically, horizontal translation, right or left, depending what D is. And then this next one is pretty straightforward. Vertical translation, up or down. So for example, let's say we have, y equals some stuff, with the function, and then plus 5, then we go up 5. Let's say y equals some stuff, minus 3, this is down 3. So this part's pretty straightforward. It's exactly what we would think it would be. No tricks, nothing, and it's pretty good to go. Plus is up and minus is down, because essentially we're taking everything else we're doing, and then very last we're taking that number and we're subtracting 5 from all the values, or we're adding 3 to all the values, or whatever we're doing for C. So that's why it's pretty straightforward. It's the very last step that we do when it comes to BEDMAS, right? Because first we take care of what's inside the function, what's in the brackets, then we multiply A, then very last we add C. All right, so with all of that said, I know that's a lot of information. I hope you took notes. If you didn't quite get everything down, feel free to rewind. Make sure you have everything down in a nice, neat pile somewhere, because this is important. This information will come up again. Here it reminds us that order of operations is important. Apply BEDMAS. So for anyone who doesn't know what BEDMAS is, BEDMAS stands for brackets, exponents, division, multiplication, addition, subtraction. Okay, so basically this indicates the order we do things. First, we do everything that's in brackets, regardless what it is. Then we do all the exponents. Then we do the division and multiplication, and very last we add and subtract. And when we don't use BEDMAS, we could get the wrong answer, right? If I was to say, okay, I'm going to add the C first before I multiply the A up here, I'm going to get a different answer than if I multiply the A first and then added the C. And the correct answer is multiplying, then adding, right? That's the correct answer. Now, if we want to indicate we should add first, then we need to add brackets around the addition in order to indicate that, right? Because there is a way to override other orders of operations, and that's by using brackets, because brackets are very first. So that indicates that we do need to add first or subtract first in some cases if there's brackets around it indicating that. But anyways, that's what we mean by BEDMAS. And when it comes to applying BEDMAS to transformations, what we mean is that we need to figure out that A and K, which are stretchings, compressions, and reflections, are applied first, right? Then secondly, D and C are applied. So in terms of our order, first what we do, so for example, if we are transforming a point or transforming an entire table of values, make sure we always do A and K first, and then D and C last. A and K can be done at the same time, and D and C can be done at the same time, but not all 4 of them can be done at the same time. And we can't do D and C before A and K. It's A and K first in any order or both together, and then D and C in any order or together. Now, each point on a parent function can be transformed using this formula. So let's say, for example, that you were given, you were told, oh, we have the point 3, 5, transform that point using the transformations. right? Now, we don't actually have a question like this. We don't actually have the transformations, so we couldn't actually do this just yet. But here they're saying, okay, whatever the k value is, we take the x value, we divide by k, then we add d, and then for y, we do a times y, so a times 5, and then plus c, essentially. So if you're just asked to transform one point, this is very useful, especially if you are able to indicate, okay, well, what's x? X is this value they gave us. What's k? Okay, k we should be able to find from the function we were given, and so on, right? So we can find all the values to figure out the answer and to figure out what 3 comma 5 gets transformed into. Okay, let's do example 1. Here it says, in words, describe the transformations that have occurred to the following parent functions. Okay, so for this first one, y equals x squared, let's see what's been done to it. Well, first things first, I noticed this 5, and it's outside of the square root, so therefore it's outside of the function, and it's our a value. So this means that we must vertical stretch by 5, or by factor 5. So that's my first thing, vertical stretch by factor 5. Now 5 is not negative, so we don't need to do any reflection. So in terms of whether or not we reflect on the x-axis, we don't. So for that, we just do nothing. Okay, I don't see any k value. I just see a c and d. So this value, plus 2, indicates that we translate left by 2 units. Okay, now for this one, we talked a bit about it earlier, but I will recap again that even though this says plus 2, there's actually a minus already here. So that means that the actual value itself would have to be negative 2, so that the two negatives would make this positive and simplify to plus 2. So that's why it's left, even though it looks like, oh, maybe it would be right by 2 units, but no, it's left by 2 units. That's not a typo. That is the correct answer. And then we have negative 4, which is pretty straightforward. Minus 4, oopsie, minus 4 just means to go down. And then we have minus 4. And then we have minus 4, which is pretty straightforward. And this just means translate down by 4 units. Awesome. Okay, the next one says y equals to the absolute value of x is transformed to y equals negative absolute value bars to x minus 5 absolute value bars. Okay, so first things first, this negative is outside of our absolute value bars, so it's outside of the function. So that means that we would do a reflection. We would reflect in the x-axis. Now it doesn't have an actual value other than 1, so therefore we don't have to do any stretch or compression vertically. Now we do have this 2, which means we do a horizontal compression. By factor 1/2. Right? Factor 1/2 because it's 1 over absolute value of k. So k is 2, 1 over absolute value of 2 is 1/2. So that's why a half rather than 2 itself. And then we have minus 5 right here, which remember the minus is part of the original equation. So it's really just plus 5. So therefore we are going to translate right by 5 units. Okay. All right, and we have one more, and then there will be a part 2 to this this session about transformation of functions. It's just that this is a longer topic, so it is going to take 2 different videos to do, but there will be a part 2 of this, which will be our next lesson, lesson 3 of the unit. But before we do that, let's get into this last one. I encourage you to pause the video, give this last one a try if you feel up to it, and then come back and see if you got it right. Okay, so this first one here, it's not negative, so we don't need to reflect in the x-axis, but it is a 3, so we do need to do a vertical stretch by 3. Good. Then the next one here, we have negative a fourth. So negative means reflect in the y-axis. So I'm just going to get that out of the way. Reflect in the y-axis because of the negative sign there. And then we also need to do a horizontal stretch by 4, right? Because remember, it's 1 over the absolute value of k, and 1 over 1 over 4 is 4. So therefore, it's a horizontal stretch by factor 4. Good. All right, then we have this minus 1, remembering that the minus is actually part of the equation, so this is actually a positive 1, and therefore we're going to translate right 1 unit. And then we have this plus 6, which just means to translate up by 6, not by 5, sorry, by 6 units. And voila, there's our answer. All right, so if you do have any questions, please do let us know on those forums, and we will see you for part 2. We're going to do a part 2 of transformations for lesson 3. That's going to include things like figuring out the points on the certain graphs and also actually doing some graphing. Because today we didn't actually do any graphing. We just talked about, what transformations would we apply and how would we graph if we were to. We didn't actually graph anything though. So that is something that we will continue to do next day. So we'll see you guys then. Bye, everyone.